1.1 point A. Determine if relations are functions or non-functions. Alright, so to start us off, we have a list. To determine if there's a function within a list, you have to look at one thing first. Is there any x values that are repeated? If so, this is not a function. Why? We'll get to when we get to this. So let's say, for instance, we have this thingy. We have 3 here, 4 here, oh, and another repeat, it's a 3, making this not a function. However, y values can repeat because they're on different points on the graph. I'll show you it later. -5 and -5 repeat, and this is okay. An example of a list with a function would be if you change this to, let's say, I don't know, a 5, and this to a 6. Since all x values are different, it's a function. I don't know what else to say. Alright, now, moving on to this. Reason you can't have two of the same x values is because you can't have two plots on the graph that are on the same x value. Why? Because every function, passes a vertical line test. So anywhere you put a vertical line, it will only intersect once. See? It doesn't intersect twice, it only intersects once. That makes it a function. An example of a non-function of this would be if I did, let's say, that, right? Here it intersects multiple times on the graph. Or let's make it more simpler. A sideways parabola. It's intersected twice, making it not a function. We're moving down to the table. Here's the table. Here's to determine what kind of function it is, as well as if it is linear or non-linear, or if it's a function or a non-function. Sorry, pardon me. So first off, we'll look, this is continuous, okay. 1, 1, 1, okay. Now we look at this. Difference between 3 and 9, that would be 6. Difference between 9 and 27 would be 18. And difference between 27 and 81, let's see. 54. So these are not constant, so this is not a linear graph. So now we take the second difference to figure out if this is a quadratic. Difference between 6 and 18, that is 12. Difference between 18 and 54, well, let's figure it out. 2, 6, that's 36. 36. This is not a quadratic either. So now, the last option you can find is if it's exponential. So we have to find a rate in which this increases or decreases. Judging on how the numbers are increasing, this looks like it's going to have a positive rate of change. So to get from 3 to 9, it would be by 3, right? To get from 9 to 27, you'd have to times 3. To get from 27 to 81, that would be times 3. So since it's 3, this would be an exponential function going, oh, that's bad, up by the rate of 3. That is 1.1a. Bye.